All right, 3.83. This problem is really getting into the stoichiometry business right here. This is a really good one, okay? Gives us a reaction. It tells us that calcium and oxygen can react to form calcium oxide, okay? And we want to eventually know how much calcium oxide we're able to make as a result of this reaction. What's the maximum amount that we can produce? But we're told how many ingredients we've got, okay? The ingredients being the reactants, the stuff on the left of the arrow. We're told that we've got 4.2 grams of calcium and 2.8 grams of oxygen. We want to know how much calcium oxide we can make. Now I look at this problem and I instantly recognize it because I've seen a lot of these as one of these limiting reagent problems. But in this case, we're not told which reactant we're going to run out of first. In these limiting reagent problems, you always run out of something first, but sometimes we're told, but here we're not. We got to figure it out on our own, and that's what makes this kind of a nice chemistry problem, okay? So what I'm going to do is draw a line down the middle, and I'm going to have a side over here on the left for calcium, and a side over here on the right for the other reactant, the oxygen. And I'm going to show you how to work this problem in a very systematic way, all right? Now the first thing that we have to do is convert both of these grams into moles. Of course, grams is not a counting unit. It doesn't tell us how many copies of everything we've done. It just tells us the weight or the mass. But moles is a counting unit, okay? So my first step is to convert everything into moles. Now on the left, I'm talking about calcium. I've got 4.2 grams of calcium. I'm going to multiply that by 1 divided by 40.08 grams of calcium. This is how many grams correspond to 1 mole. It's the number from the periodic table of the elements. Now when I do that, I quickly find that I've got 0.1048 grams, or sorry, moles of calcium. That's what I have available in the 4.2 grams. Now what about the oxygen? The problem states I've got 2.80 grams of O2 gas. I'm going to convert that to moles, my counting unit. It just so happens 32 grams is required to make 1 mole of O2. Again, this is O2, the diatomic version, and as a consequence, the amount that they've given me to work with in this problem is 0.0875 mole of O2. So all we've done is converted grams into moles in both cases. Now the reason why I've done that is because what I would like to do now is to predict how much product we're possibly able to make from both of our starting materials. Okay, so from 0.1048 moles of this stuff, how much product can I make? And the way we do that is we look at the balanced chemical equation to help us. And in this particular case, it tells us that I can make 2 moles of my product, CaO, from every 2 moles of my calcium. It's essentially a 1-to-1 ratio. As a consequence, I know from 0.048 moles of calcium, I can also expect to make, the most I could ever make is 0.1048 moles of calcium oxide. It's the most I could ever make from that amount of starting material. Now I do a similar computation here for the other reagent. This is how much oxygen I have in moles. The ratio is different here because the stoichiometry says I can make 2 moles of oxygen for every 1 mole. Sorry, 2 moles of the product for every 1 mole of oxygen. Okay, so I actually have to double the number of moles. That results in 0.175. CaO. So this is what's possible from my oxygen supply, and this is what's possible from my calcium supply. So I have two numbers, okay? Which one is correct? The one that will be correct when you're working a limiting reagent type of problem is always the smaller one. Here that's going to be the result for calcium. Remember, what we computed here is what I can possibly make, how much of my product I can possibly make from the amount of starting material that I've been given. The number which is smaller is going to reflect reality, because after you create this much of product, you're going to run out of one of your ingredients. You're going to run out of one of your materials, and the reaction is going to stop. It will no longer proceed, okay? So when you're faced with a problem like this, a limiting reagent type problem, which is one of the harder types of problems for this chapter, okay? What I encourage you to do is write out the balanced chemical equation. Take the starting materials. If you're given grams, always convert to moles. Moles is your counting unit. Always got to go to moles, okay? I did that first, and then in my next idea, I decided I was going to figure out how many moles of product I could possibly make. What's the maximum amount I could possibly make from each material? So from my calcium supply, I can only make this. From my oxygen supply, I can make a little bit more. But the thing is that in this particular set of circumstances, I run out of my calcium, right? Because that's a smaller number. Once I make that much, I'm out of calcium, and I cannot possibly make any more product because I'm out of calcium. I just ran out. You with me on that? All right. So the cool thing about this then is now that I've identified this one as my limiting reagent, it's a key vocabulary word, just limiting chemical, the one that you're going to run out of first, okay? I can now figure out exactly how much calcium oxide will be produced. And I've, in fact, already done that. This is how much will be produced. And if I want to convert that to grams, it's no problem because I know I have this many moles. I simply need to multiply by my molar mass, which is 56.08 grams per 1 mole for the calcium oxide. Which tells me I should expect 5.88 grams of calcium oxide to be produced. I've run out of this, and I will have some of my oxygen left over after the reaction is complete and it stops. Now, bonus problem here. You weren't asked this in the textbook. But what if I asked you to figure out how much oxygen you have left over after the reaction stops? We know we had 2.8 grams to start, and that was actually too much. Can I figure out how much oxygen is left after the reaction is done? Or how much is left over? I think I can, because of the beauty of the stoichiometric or stoichiometry business, right? So I know a lot about my reaction at this point. I know how much calcium oxide in grams I'm going to make. I know how many moles that corresponds to. I know how many moles of calcium must have reacted before I ran out. In fact, earlier in this problem I said I can react my 0.1048 moles of calcium and then I'm done because I ran out of calcium. There's no more to react. Can I do a similar type of computation to figure out how many moles of O2 must have reacted with that much calcium? I think that shouldn't be too hard because I have the balanced chemical equation. I see that 1 mole of O2 reacts for every 2 moles of calcium. See where I got that from? So this is how much reacted. This is my stoichiometric ratio. Now because of that, I can then project that 0.0524 moles of oxygen was used in this reaction when this many moles of calcium reacted. So, in fact, this is how much reacted, right? Now back to my original question. Can I figure out how much was left over? Well, yeah, I can, I think, because I know what I started with. Originally, I had 0.0875 moles of oxygen. That's what my reaction system was charged with, or what was added to begin with, okay? That's my initial amount, and it looks like in the reaction, I consume 0.0524 moles of this gas. So if I do some subtraction, it turns out 0.0351 moles oxygen must be remaining. Okay, so I know a lot about this system. I started with 4.2 grams and 2.8 grams of oxygen, or calcium and oxygen respectively. That was this many moles of calcium, that was this many moles of oxygen. They're physically equivalent, as different units. I did my limiting reagent part of the problem to realize that calcium was the limiting reagent. It's what I was going to run out of first. After the reaction, I'm not going to have any of my calcium left. It's going to be completely gone because all of it's going to be converted to the oxide, and I'm going to yield 5.88 grams of that calcium oxide, which is this many moles. As a result of that, I'm going to use oxygen in the process, as the reaction suggests. However, I'm not going to use all of it because I started with too much. There was too much in my reaction system. There was excess, as chemists like to say. How much was left over? 0.0351 moles. Because this is what I started with. This is how much I computed that I consumed through using the stoichiometry. This is what must remain, okay? So I can do a lot with a balanced chemical reaction and stoichiometry.